Hello guys, and welcome to my next video tutorial. This video tutorial follows the previous video tutorial that I recorded where we're looking at how to convert binary into hexadecimal and hexadecimals into binary. In this video tutorial, guys, we're just going to be looking at how to convert hexadecimal to denary and denary to hexadecimal. So I'm on unit 1.5.2, sorry, and that's going to be found again on the IGCSE Computer Science textbook. And today we're going to be looking at the steps we need to take to convert hexadecimal into denary. So to convert hexadecimal into denary, guys, it's a pretty straightforward step. First of all, you are given the hexadecimal values, and all you have to do is put the powers of 16 from right to left on top of each of those values and multiply it by those hexadecimal values. So in this example 1, you have the hexadecimal value of 45A. We know that A in hexadecimal is actually represented as a 10. What we need to do is put the powers of 16 on top of each of these hexadecimal values and multiply it by the value we have. So if we're looking from right to left, A is going to have the hexadecimal power of 16 to the power of 0, and then 5 is going to have 16 to the power of 1, and 4 is going to have 16 to the power of 2. So when you multiply A, which is 10 times 16 to the power of 0, as we have here, we have 10 times 1, and then of course 5 times 16, which gives us 80, and 4 times 2, 56, because that's 16 to the power of 2, which gives us 1024. And these values all added up together gives us the denary number of 1114. So this is a very simple step on how to convert hexadecimal numbers into binary. The same thing goes for example 2. We have a hexadecimal value of C8F. Again, put the powers of 16 looking from right to left, from F, which is 16 to the power of 0, and then from 8, 16 to the power of 1, and C, 16 to the power of 2. So you just have to interpret these alphabetical letters we have into hexadecimals, and we know C is 12. So 12 times 16 to the power of 2, which is 12 times 2, 56, gives us a total of 3072. And then 8, of course, is multiplied by 16 when we get 128. And 15 is multiplied by 1 because 16 to the power of 0 is 1, and we get 15. When we add up all these values, we get a total of 3215. Now we're going to be taking some examples to find out how to convert hexadecimals into denary. So we're going to take the first example, which is activity 1.6a, okay? And I'm going to be writing the main theme, which is basically converting hex numbers. So I'm just going to represent it as hex into denary numbers, so denary. So the first example we're going to be taking from 1.16 is A. And the A, oh God, sorry about that, guys. Let me write this really properly so we can see really well. Okay, there. Okay, so 1.6, and we're going to be taking example A. And on example A, we're supposed to convert 6b, which is a hex value, into denary. So as I said, the first step we're going to be doing is to write the powers of 16 on top of each of these hexadecimal values, looking from right to left. So the first power is 16 to the power of 0. The second one is 16 to the power of 1. And then, of course, we're going to multiply these values by the powers of 16. So 6 times 16, which is 16 to the power of 1, plus b, that we know that b is actually 11. So 11, remember we said a in hexadecimal is 10. Up till you get to f, which is 15. So you keep going, b is actually 11. And, whoops. Yeah, so B is actually 11, and then C is actually 12. So because we have B, we know that that's going to be 11 times 16 to the power of 0, which is going to be 1. Finally, we're going to be adding up our answers, and 16 times 6 is going to be 96. So 96 plus 11 times 1, which is going to be 11, our final answer is going to be 107. So this is our answer for this question. So this hexadecimal value, 6b, is actually equivalent to 107 in denary. We're going to take another example, which is the B1, so example B, and this one is 9c, and pretty much we're going to do the same. We're going to be looking from right to left and put in the powers of 16 on top of these values, so 16 to the power of 0, and then we're going to write 16 to the power of 1. The same thing we've done before. So the first step we know is to put the powers of 16 looking from right to left. So starting from 16 to the power of 0 to 16 to the power of 1. The next thing we're going to do is multiply these values by the powers of 16. So here we have 9 times 16. And of course, we're going to add this to C, which is 12 times 16 to the power of 0, which is going to be 1. So when we multiply 9 by 16, we get a total of 144. And we pretty much add that to 12 because 12 times 1 is 12. Your final answer is going to be a total of 156. So that's that, guys. Then we're going to be looking at the next example, and the next example is, again, we're going to be looking at example C. So we're going to move on to example C. And example C is pretty much the same thing again. It's 4a. So if we wanted to convert 4a, so we're going to do that on the next sheet. So example C is going to be 4a. So we needed to convert this hexadecimal value into denary again. So what we're going to do is the same thing as usual. We're going to write 16 to the power of 0, and we're going to write 16 to the power of 1. So we're going to be, again, multiplying the values that we have in here by the powers of 16. So in this case, we're going to say 4 times 16 to the power of 1, which is going to be 64, because 4 times 16 is 64, right? And then we're going to be adding a times 16 to the power of 0. We know that a is 10, so 10 times 16 to the power of 0, which means 10 times 1. So obviously we're going to be getting 64 here, so 64 plus 10, which is going to give us a total of 74. So this is going to give us 74. We're going to do another example, but this time I'm going to take, okay, I think I'm going to be clearing the frame here, guys, on this frame. So I'm going to take the last example that I wanted to do for today, and this would be example E for this exercise. And then I'd like you guys to try out doing D, F, G up to J. So just try it out as a practice work to see if you understood. So I'm going to be doing example E, and example E has 3 different hexadecimal values. So in this case, we have 1, and then we have F, and then we have F. The same thing we're going to do is write the powers of 16 at the top. So 16 to the power of 0 at the top, 16 to the power of 1, and 16 to the power of 2. And then, of course, we're going to be multiplying the values by the powers of 16. So 1 times 256, because this 16 to the power of 2 is 256. Plus F, we know, is the same as 15 in hexadecimal, so 15 times 16. And of course, we're going to be adding plus F again, which is 15 times 16 to the power of 0, which is 1. So 15 times 1. So finally, we're going to be getting a final value of 256 on the side. And of course, we're going to be adding it to 15 times 16, which is going to give us 240. And then, of course, we're going to be adding this to 15 times 1, which is going to give us 15. So eventually, our final answer for this question is going to be a 511, which is the equivalent denary value for this hexadecimal value here. So now, guys, we're going to be looking at the next activity. So I would like you guys to practice doing, again, as I've mentioned, from D, because I've already done A, B, C as an example in E, so you can do D, F, G, H, I, J. So we're going to be looking at how can we convert a denary number into hexadecimal, and basically we have 2 methods. The first method is whenever you have a denary number, you're just going to look for what hexadecimal power, when multiplied by a digit and added together, can give you 2004, which is what they did here in method 1. The second example is the one I prefer mostly to use because it's kind of more accurate than this trial and error method. And this one is basically having a successive division of 16 by 16, with the denary number that you are given. So in this case, the denary number is 2004, and we're supposed to convert that into hexadecimal. So we successfully divide it by base 16 or 16, so we get remainders. So 16 goes into 2004 125 times, remainder 4. 16 goes into 125 7 times, remainder 13. 16 goes into 7 times, 0, remainder 7. And then, of course, we look at the remainders looking from bottom to top, so that would be 7, which is 7 in hexadecimal, 13, which is actually represented as a D, and 4, which is represented as a 4. So this is this method. It uses long division to be able to get the final answer, and this is the one that I prefer most likely to use, because then you don't have to waste time thinking about what number can you multiply with this power of 16 to give you the denary number. So we're going to use this method to solve activity 1.7. And the first example is we're going to be converting 98, which is a denary number, into hexadecimal. So we have 98, so I'm going to write denary into hexadecimal. So denary into hex values, I'm just going to write it as hex. And the example gives us the first option, which is 98. So we have this hex denary number, and we're supposed to convert this into hexadecimal. So we're going to divide this by 16. So 16 divided into 98. So how many times can 16 go into 98? It can actually go 6 times. because if you multiply 16 by 6, you get 96, which is smaller than this number. So I'm going to represent remainder as an R. So 16 goes into 98 6 times, which is 96. 98 minus 96, we still get a remainder of 2. We still continue to divide because we don't have a 0 in this line. Until we get a 0 in these numbers here, then we stop. We divide again 16 by 6. Unfortunately, 6 is smaller than 16, so 16 can't divide 6, so that means we're going to write a 0 and a remainder of 6. And then we can stop now because we no longer have a number to divide, so we're going to stop here, and we're just going to look at our answer from bottom to top and read it as that way. So our final answer for this denary number to hexadecimal is actually 62. It's not read as 62 because we're converting into hexadecimal. Remember, hexadecimal is represented from 0 to 9, A to F, and so we consider this as 62 when read. So the answer for this denary number into hexadecimal is actually 62. I'm going to clear this frame again, and we're going to do the next example. So the next one is how do we change 227, which is a denary number, into hexadecimal. So we're going to write that here. So it's pretty much the same process again. So we're going to do a long division for this one as well, and we divide this by 16. So 16 goes into 227 how many times? It actually goes 14 times. Because when you multiply 14 by 16, you actually get 224. So it goes into 227 14 times with a remainder of 3. And we have to keep going to divide because we still didn't get a 0. So that's the rule. You have to keep dividing until you get a 0. So 16 can't divide 14 because 14 is smaller than 16. So we're going to put a 0 and a remainder of 14, which is the number it couldn't divide. So we're going to stop here because we got a 0, so we don't continue to divide. Now we read our answers from bottom to top, and our final answer is going to be 14.3, not 143, guys. Again, it's read as 14.3 individually because this is hexadecimal. So which means we're going to get 14 is represented as an E, so it's going to be an E3 as your final answer. So this would be the final answer. Okay, one last example before I close this video is example C. So we're going to be dividing again. We're going to be converting 490 into hexadecimal. So we do the same process of dividing this number by 16. And 16 goes into 490 30 times because that's the smallest. 30 times 16 is 480. And it gives a remainder of 10. And now 16 can go into 30 by 1 time because it's the smallest value it can go into it. And you get a remainder of 14. So because 1 times 16 is 16 minus 30 is 14. And we have to keep going again until we get a 0. 16 can't divide a 1, so that's a 0, remainder a 1. So we read our answer from bottom to top, and we have 1, 14, and we have 10. So this is considered as 1E, and of course we know that 10 is represented as an A in hexadecimal. So this is pretty much, guys, how you convert denary into hexadecimal in a very simple manner and also very accurate. I would like you guys to try to do D to J on your own, just as a practice work to see if you understood what we've done. And next time we come, we'll be looking at the use of hexadecimal systems in terms of memory dumps and HTML, and also in terms of MAC addresses and web addresses. And that's pretty much going to round up this topic once we come next time to the next one. I hope you guys have a great day, and I hope you share this and with people or students that you think really need help on understanding these topics in IGCSE, and let me know if you have any questions in the comment section. Have a great day, everyone, and I'll see you next time.